Yes. Clock.
Okay. Last year, Jan-Simon Möller gave his talk at 4 o'clock. This year, he's giving it at 3 o'clock, and it will give us an update about how Linux compiles with LLVM. Let's applaud Jan-Simon.
All right. Hello, everyone. So, the Linux kernel on Dragon Wings. So, what's our topic here? So, who has heard about LLVM? Raise your hands. Oh, perfect. Who has heard about, or who has used Clang, which is the compiler frontend? Yeah? Okay. So, our project is about compiling the kernel with Clang. So, okay. From the short poll, you all know LLVM. Starting as a low-level virtual machine, and we want to use the compiler, but also we want to use things like the code analysis, checker, and we want to be able, in the end, as a goal, to use code refactoring. So, why? Well, compiling the kernel takes quite some time. If we can speed that up, hey, even better. Well, still, that's about compiling, yeah? For the linker, we still rely on the GNU-LD, yeah? So there are still two sides of the story. Compile times are faster. We have a lot of potential in Clang, and there is still a lot of work and a lot of things which can be done in terms of optimizations. For example, one student last year was trying to get the LLVM IR, the intermediate representation of the kernel. And then he wanted to do some research or apply optimizations or whatever on the intermediate language here. So I think that has a lot of potential. We also had a GSOC project where one student made sure that the checker, which is the static analyzer, is able to run against the Linux kernel. Yeah, there are a few glitches on the checker side that has been solved, and we can now get static analysis runs on the kernel. It works. You can see it on our build bot. It's available just on the checker subfolder. Still, there is quite some work to do. Well, the checker was first done with kind of user space in mind. Yeah, so if you do a checker run against the kernel, you still see quite a few false positives or things that don't apply in terms of the kernel. But it's a really good tool because it shows you the path in where the issue happens, and you wouldn't believe how deep those paths are sometimes in the kernel. Yeah, like 36 steps. That's nothing you can find out with just a human review or inspecting the code. Yeah, if it descends 36 steps. Also, Clang or LLVM is used in a lot of other projects, and for example, RenderScript uses it. It's used. It's meanwhile part in the Android NDK. Well, there were some rumors they wanted to compile all of Android with Clang. Well, let's see what happens. It certainly has the advantage that in terms of Android they can kind of focus on just one compiler. Well, let's see. It's part of the Gallium 3D, LLVM pipe, drivers and others. And if you are interested, there's a talk tomorrow in the LLVM dev room from Sylvester. He does a full rebuild of Debian with user space with LLVM. So, what about our LLVM Linux project? So, we want to compile the kernel for multiple architectures with the Clang LLVM toolchain. And we want to fix issues which we find on the way. That started out with kind of Clang not supporting whatever nitty-gritty feature that was used in the kernel. And on the other side, there are a few things in the kernel which are kind of horrible, and GCC doesn't complain. Yeah. No offense, it's just kind of the kernel and GCC, they were always kind of developed driving each other, so and they were kind of pushing the boundaries. So now Clang usually is a kind of more, goes by the book, or goes really by the standard. So we find a few issues where, well, the code shouldn't actually work. Still GCC eats it, and so we had a few things to fix in LLVM. We are kind of a meta project. We collect the patches, we kind of split them up and feed them into the upstream project. That worked out really well. Right now with LLVM 3.4, the latest stable release, you need no patches to LLVM. Still, we need a few patches to the kernel. Because, well, compiler flags need to be set, or the compiler needs to be reset. So there are a few issues in the kernel. What else? So, for LLVM part, all patches which are needed are upstream. Ongoing in 3.5, and David Woodhouse is doing an awesome job here, we also get rid of one nasty piece, which is code 16 support. That's for booting the x86 CPUs. And that was not present in Clang. Meanwhile, we have it, so we can get the boot up part solved. Up to now, we still used for just these parts GCC, but we have that now, and one big thing here, which is in the kernel, that is we still have to upstream a lot of kernel patches. They are. Some are small, some are just enabling other compilers to work with the kernel. Others, they deal with a few larger problems. One is, for example, what we call FLAs. Don't mix it up with VLA. VLA is perfectly fine, so variable length array, that's perfectly fine. But variable length array in a structure is kind of evil, and Clang doesn't support it. It's actually even not part of the C standard. Still, we have such pieces of code flying around, especially in crypto and in the NetFilter stack. And regarding crypto, the problem is that code gets now copied over in every place of the kernel, like Bluetooth. The AES encryption in Wi-Fi now uses such pieces where you end up having variable length array in a structure, or you kind of nest a structure with a variable length array into another structure. Boom. That happens a lot, and that's a big problem right now. We talked to the Clang guys, and they said, no, it's nothing we want to support, and it's not part of the C standard, and actually it's evil. Last year during the Plumbers Conference, we had Linus in the room, and after looking at it, he said, it's actually bad. But it takes quite some time to figure this out now and get the patches upstream. Now, just if you happen to work on some code, yeah, please make sure you don't use these in new code. A difference in Clang is weak alias and section attributes. The kernel uses that in when we do the module, yeah, driver modules. We assign the module init. Once we make this connection, we use a weak alias. The problem is GCC makes just this side of the alias inherit all the sections on this side. Yeah, so the upper element gets all the section and all the annotations from the symbol we link to. Clang doesn't do that. Yeah, so that's a difference. Right now, it's no problem. We just apply the necessary attributes at this point over here. Right now, we also do not use the integrated assembler of Clang. It would be possible to compile and link with Clang at once. Yeah, and kind of LTO-ish apply more optimizations. For x86, we still have a few things to sort out. Code 16 was one. With that kind of solved, we plan to enable the integrated assembler again and give it a new run. For ARM, we have a few issues with the assembly style used in the kernel versus what Clang expects. So, if you want to try it out, help us. Tomorrow is another talk in the LLVM dev room. B, you can try it out. We have a website, link follows, and we have a JIT tree which hosts a set of make files which allows you to pull everything, build everything, so you get an x86-64 kernel, or what else do we have? vExpress as QEMU target. We have also a few boards and a few Android kernels, kind of Nexus 7 is supported. So you could try that out on your PC or on a real target. It's kind of always a moving project because we have two upstreams. Yeah, so sometimes it breaks because, well, the merge window of the kernel opened or the merge window of LLVM opened. Yeah, so be aware. Sometimes the patches do not apply, but right now with no patches to LLVM and just the kernel, that actually works most of the time. All right. What else do we have? If you want your target, your board supported, feel free to post a patch on the mailing list. It's not that hard. And what else? Yeah. Contact. Here's the website, llvm.linuxfoundation.org. We have also a mailing list, IRC channel, LLVM Linux on OFTC. And feel free to contact us. All the information is also in the picture over there. All right, questions? Just a minute.
Hello. On the beginning of the talk, you mentioned code refactoring.
Louder, please. I can't hear you.
On the beginning of the talk, you mentioned code refactoring. What are the goals of the code refactoring you use LLVM?
Yeah. So the idea is kind of Okay, so for example, Google, when a check-in at Google happens, they compile it for production with GCC, but in parallel with Clang for the debug output. And they have it instrumented like that for kind of the most obvious stuff, or the kind of recurring errors, they can even find out through Clang what's wrong and kind of propose a patch already. Yeah, so that's kind of the what's possible. We could kind of do a sparse version, whatever, yeah, or Coccinelle-like tools with Clang, yeah, to find and sort of fix issues in the kernel. But right now, that's just ideas. There's no specific work on that right now. Okay.
Regarding the to-do with the variable length thingies, since the LLVM maintainer said no, they're not going to support it, so the to-do is to remove all of them from the Linux kernel? And do you have currently patching them out, or what's
we have patches for a few things. Mostly, it's not that hard to move things out of the structure. Yeah, it's kind of just moving it out and accessing it just directly. So that's not the point. The problem is, at the moment it's used in a few crypto bits, and right now the maintainers are not in favor of changing it.
And so, if
that probably needs some time. And some, time to convince them. The problem is now that code gets copy and pasted.
Yeah, I understand.
That's our main problem right now. We have a few patches and some went upstream, like the USB Gadget FS used it, and we met the maintainer and said, okay, let's just do that. So. In principle, yes, we would have to find and to remove all the places where we use Flace. It will not be supported.
So if there's a driver using it because it was comfortable to use it, then it won't work and I need to fix it manually.
Yep.
Okay.
Okay, thanks.
Thank you for your talk.